All right, so we're going to go over the laws of exponents, the exponent rules. We're in page 17 of your notes, and let's get started. So the first thing is whenever you add and subtract monomials, so that's single terms, you're not going to do anything with the exponents, right? That's combining like terms. Okay, so just be careful. Do not, whenever you're adding or subtracting, you do not change the exponents at all. Okay, so the next thing we're going to talk about is the product rule. So the product rule is whenever I have x to the power of a times x to the power of b, that's going to be equal to x to the power of a plus b. Okay, you add the exponent. All right, and then another form is if I have coefficients for both of those monomials. So what you do is you actually multiply those two coefficients. So it would be c times d, where c and d represent constants, and then it'll still be x to the power of a times b. So if they both have a number in front of them, you're going to multiply those two numbers. Okay. Oh yeah, this is plus, my bad. Sorry, thank you. Okay, let's do an example of that. This is not in your notes. So I have negative 11 x to the power of 4 y to the power of 5 times 2x to the power of 5 times y to the power of 2. So what's going to happen is I'm going to multiply the negative 11 and the 2. So negative 11 times 2. And then x, right? And so the big thing to remember is that you only do it with the same bases, with like bases. So I'm only going to combine the x with the x. So that's going to be 4 plus 5. And then y to the power of 5 plus 2, right? So you only combine, and since we're multiplying, we add the powers. So negative 11 times 2 would be negative 22. And then 4 plus 5 is 9. And then 5 plus 2 is 7. So this would be negative 22 times x to the power of 9 times y to the power of 7. Okay, make sense? Any questions? Okay, let's go back to the notes. And so now we're going to go over the power rule. So the power rule states if I have x to the power of a, and then in parentheses, I raise that to another power, that means I'm going to multiply those two powers. So this is going to be x to the power of a times b. Okay. And then this is where a lot of people get confused. If there's a constant coefficient in front of that parentheses, in front of that x to the power of a, that c is also going to be raised to the power of b. So this is going to be c raised to the power of b times x to the power of a times b. So basically, you distribute this exponent, but we only distribute because there's multiplication. If there was addition or subtraction, you do not distribute inside the parentheses, okay? So only distribute the exponent when there is multiplication, no addition or subtraction. That's where a lot of people mess up. Okay, let's do an example. So here I have 6x squared y squared, all raised to the power of 2. So I'm distributing this exponent since it's just multiplication. So it'd be 6 squared times x to the power of 2 times 2, and then y to the power of 2 times 2. So what's 6 squared? 36, good. 2 times 2 is 4, so this is going to be x to the power of 4 times y to the power of 4. So another way to think about this, right? 6x squared times y squared, all quantities squared, is the same thing as 6x squared y squared times 6x squared y squared, right? And so 6 times 6 is 36. And now you can add the two exponents. So this would be x to the power 4, y to the power 4. So those two different ways you can do that. Okay. But once it starts getting to bigger numbers, like if this was a 6, it'd be hard to do that 6 times. Okay. Any questions about that? Okay, let's go to the quotient rule. So if I have two monomials being divided, x to the power of a divided by x to the power of b, this is going to be x raised to the power of a minus b. And then again, if you have coefficients, you do divide those coefficients, whether it's you either simplify a fraction or you actually divide out. Sometimes they will divide out a minus b. So like if c was 4 and d was 2, 4 divided by 2 would give me 2. Okay, so let's do an example about that. So here I have 18xy to the power of 8 divided by 27x to 7 y cubed. All right, so I messed up. I should have done something else first. All right. Yeah, let me go back. Hold on, I want to do something else first. Let's do the negative exponent rule first. So the negative exponent, if I have x to the negative a, that's going to be 1 over x to the power of a. So to get rid of the negative exponent, you put it in the denominator. Okay. And over here, if you have a coefficient, you're going to leave that coefficient in the numerator and still use that x to the power of a. So you still keep the a value. So if this was negative 2, it would be 1 over x to the power of 2. You keep the number, you're just getting rid of the negative. Okay? So negative exponent means we put it in the denominator. So let's go. So these are the two rules we just did, the quotient rule and the negative exponent. So let's do two examples on that. So over here, I'm going to do this one first. So negative 2x raised to the power of negative 2. We're going to use the power rule, right? So we're going to raise negative 2 to the power of negative 2, and then x to the power of negative 2. So negative 2 raised to the power of negative 2 means this is 1 over negative 2 quantity squared times x to the negative 2 means 1 over x squared. Okay, so getting rid of the negatives, I kept the 2's, right? What is negative 2 squared? 4. Positive 4, right? Negative 2 times negative 2 is positive 4. So this is going to be 1 over 4x squared. Okay. Right, so if I come over here and do the quotient one, so the 18 and 27, that doesn't divide out, right? So I have to simplify the fraction. So 18 over 27, what can I divide by? 9. 18 divided by 9 is 2. 27 divided by 9 is 3. So 2/3, right? So 2/3. And then I have x to the first power. Remember, if there's no exponent, that means it's a power of 1. And then divided by x to the power of 7. It's the numerator minus the denominator. So it's going to be x to the power of 1 minus 7. And then y to the power of 8 minus 3. Huh? Yeah, I was going to bring that up right now. So 1 minus 7 is negative 6. So 2/3 x to the negative 6. and then 8 minus 3 is 5, so y to the power of 5. I have a negative exponent, so that means it's going to go into the denominator. All right, so it's going to be 2 over 3. The y to the 5th power is going to stay in the numerator, and then the x to the negative 6 is now going to be in the denominator, x to the power of 6. Okay, now what she was talking about is canceling stuff out, and that's how I kind of approach it. So if I have one x in the top and 7 at the bottom, if I cancel one out, that means that exponent, now I have 6 at the bottom, right? And if I have 8 y's in the top and 3 in the bottom, I can cancel out 3 from the bottom and 3 from the top. 8 minus 3 would be 5. Okay, so you're still doing this process, you're just doing it in your head, basically. Okay, so either way you prefer, as long as you end up with this answer. Okay, does that make sense? All right, good, good. The zero exponent rule, this is pretty easy. X to the power of 0 is going to be 1. Or if you have c times x to the power of 0, x to the power of 0 is 1, so c times 1 would be c, whatever that constant is. Okay? And then finally, the rational exponent rule. That's if I have x raised to the power of a fraction, the denominator of that fraction is going to be the root, and the numerator is going to be the power. So this is going to be x to the power of m with the root of n. So whatever the denominator is the root. So the nth root of x to the power of m. And so you should be able to go backwards from here and here. So here I have the 5th root of x to the power of 4. This is equal to x to the power of 4/5, right? The denominator is the root, the numerator is the power. And then vice versa, over here I have x to the power of 3/2. So that's going to be x cubed squared, okay? Remember, the square does not have a number, so it's just the square root means it's 2. So if you have the square root of x to the power of 3, or that's whatever we have, 5, that means x to the 5/2. Okay, so no number there means it's just a denominator of 2. Okay, any questions? All right, so let's do those two examples at the on the bottom. So I have 2y raised to the negative 5th n to the power of 4, all raised to the power of negative 3, divided by 6y to the power of 7 n to the negative 5th. Okay, let's see if this is too big. All right, so what should we do first? What do you want to do first? Let's distribute that negative 3. Okay, good. So 2 to the power of negative 3, y to the power of negative 5 times negative 3. Remember, you multiply. And then n to the power of 4 times negative 3. Divided by, and then we're going to keep the denominator the same. 6y to the 7 n to the negative 5th. And so let's simplify all that we have. Well, hold on. 2 to the negative 3. What would that be? So so 2 to the negative 3 means 1 over 2 cubed, which means 1 over 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8, so 1 over 8, right? Does that make sense? So this would be 1 over 8 times, now don't forget we have the 6 in the bottom. We're going to keep all that the same. And then let's multiply the top. So -5 times -3, 15. And then 4 times -3, -12. So I have 1 over 8 times y to the 15th n to the -12 divided by 6 times y to the 7th times n to the -5. Now, this is where the whole canceling kind of gets confusing because I have negatives all over the place. So what I would do is I would just subtract. So I'm going to bring this 6 out to the front with this coefficient. So I'm just going to leave that as 1 over 8 times 6 and then worry about the variables. So I have 15 on top, 7 in the bottom, so that's 15 minus 7. And then I have -12 on top, so that's -12 minus -5. So don't forget, there's two negatives now, because it's -12 minus -5. Be careful with that. Oh, crap, sorry. Okay, so 8 times 6 is what? 48? And then 15 minus 7, huh? 8. And then -12 minus -5, so I add 5, huh? -7, and to the -7. So my final answer is going to be y to the power of 8, because that's all that's left in the numerator, over 48 n to the power of 7, right? Because a -7 means I put it in the denominator. And this is my answer. Make sense? Any questions? Okay, go ahead and try this second one, and then I'll go over it in a little bit. All right. So we have 4 to the power, or 4 times c to the power of 3 times b to the power of 4 divided by 2 times c times b to the power of -3, all raised to the power of -5. Now notice here, the 2 is not inside the parentheses. So 2 is not going to get raised to the power of -5. So be careful with that, because it's the only thing that's going to get raised to the power of -5 is c and b. Okay, so what that means is I technically could already divide 4 by 2, right? So what's 4 divided by 2? 2, right? So I'm dividing 4 by 2 to get me 2. And then c cubed and b to the power 4, nothing's going to happen to that, right? And then I can raise the denominator to the power of -5. So c raised to the -5 times b raised to the power of -3 times -5. Does that make sense? So nothing really changed at the top. The only thing was we divided 4 by 2 only because it wasn't inside the parentheses. If it was inside the parentheses, then that would be a different story. All right. So let's multiply -3 times -5, which is 15. That way now all we have to do is just subtract. So -3 times -5, that would be +15. And then we can subtract. So it would be 2 times c raised to the power of 3 minus -5. All right. And then b raised to the power of 4 minus 15. So 3 minus negative 5 is plus, so 2 times c to the power of 8. And then 4 minus 15. Negative 11, yeah. B raised to the power of negative 11. And so then my final answer would be, all I have to do is move that b to the power to the negative 11 raised to the bottom. So 2 times c to the power of 8 divided by b raised to the power of 11. And that would be my answer. Okay? Any questions? All right, so this is all just review from Algebra 1 and Algebra 2. Go ahead, you're going to start working on your Delta Math assignment. It is a lot of problems, but again, you're going to have tomorrow in class to work on it as well. Okay? I'm going to start putting your grades from last week, those 2 assignments, okay? Any questions? All right, you can go ahead and